we've dealt with the theory of momentum now. Now, as I promised, let's look at some examples, okay? And you can go through, but stop and start it. Do it with me. Go through the processes I am going through. Just sitting listening to it, no, it's not going to work. It really is not. You got to work it with me. They're quite short, they're quite sweet, they're to the point. And in fact, every single one of these is a variation on what you're going to be asked, one way or another. Okay, let's have a look. Question or example number 1. Example 1. A car is traveling at 120 kilometers per hour. I picked quite a cool car, I reckon. Okay, and it is the, I don't know, Lamborghini, let's see which it is. Oh, it's the Lamborghini Huracan, LP6104, whatever. Okay, still pretty cool. It is traveling at 120 kilometers per hour with a mass of 1,200 kilograms. Okay, all right. And it's approaching another car. So we've got car A over here, all right. Car A is traveling at 120 kilometers per hour. Because what did Kevin say? Kevin said, draw it. He's drawing it. This is the initial situation. 120 kilometers per hour. And the mass of this car, I said, was 1,200 kilograms. Okay. Then it's approaching another car traveling at 80 kilometers an hour. So let's say this is A. And now this is car B. And we are traveling at 80 kilometers per hour, 120. So this is V, and this is V of this car. And we said mass of 800 kilograms. 800 kilograms. We are both going in the same direction. Okay, critical. So, and then a collision ensues, and the wreck moves off in the same direction. Calculate the velocity of the wreck. Okay, so this is my initial. This is initial. Okay, or before. I like before and after because it reminds me of those photographs, before and after hair or exercise or whatever the case might be. So this is my initial, and I said, okay, calculate P initial. Okay, this is initial. Let's just do after or final. This is after collision. Okay, they say the wreck moves off. Okay, and they are together. So car A and car B are together, which means that the mass is now going to be 1,200 plus 800, which is 2,000 kilograms. Okay, right, that's that. So I've drawn it. Okay, now the next step is calculate P initial. Right, here we go. P initial is equal to M times V initial, correct? Well, in this case, I've got momentum of car A, which is, let's call it green, is going to be 1,200 times, oh, hang on, whoa, stop the bus. Why? Because it's 120 kilometers per hour. And what must I do straight away? Straight away, no, I'm going to go and do it in red. I must convert to meters per second. Okay, medium. Sorry, I changed my pen there by accident. That's going to be, go back to meters per second. Okay, I cannot use it in terms of kilometers per hour. So I change it to meters per second. Right, I just want to try the thick pen. I hope it's okay. So what do? I say it's 120 kilometers per hour. How do I change this? Well, I say, what do I want? I want meters and seconds. How do I change kilometers to meters? I times by 1,000. How do I change hours to second? I times by 3600. So there's my conversion factor, 120 times that divided by that, and hey presto, I have got an answer, and I'll put the answer in green. It's going to be equal to 33.3. So I change that to 33.3. Now I'm going to take it as blue, the next car. This one is 80, so I change that to meters per second, and it becomes 22.22 meters per second. I probably haven't taken the whatever. So it's that plus this one, isn't it? 800 times 22.2. So my total initial momentum of these two vehicles is going to be equal to 39, that is 39,960 plus 17,777. Okay, when you do it, you've got a calculator. I'm just rounding stuff, and we go here, we get 57,737.8, and my units are kilogram meters per second, right? Then I calculate P final. So I say, okay, P final is equal to 2,000 times V final, but I don't know it. So 2,000 times V final is that. The next step is I put the two equal to each other. Therefore, P final must be equal to P initial. Okay, let me move up a little bit here. And therefore, 2,000 times V final must be equal to that 57,737.8 kilogram meters per second. Therefore, V final is going to have to be 28.86 meters per second, which is approximately 104 kilometers per hour. Okay, so what happened? Car A slowed down and car B sped up. Can you see it? What happened was this. This car was going faster than this one. It hit. This one slowed down. This one sped up, and off they went together. And that is how it works. That's the split second though, remember, right? The moment this collision has occurred, new forces come into play. Friction comes into play, okay? That's what's going to eventually stop the wreck, all right, is friction. Right. Now, let's have a look at another problem, all right? Example number 2. Okay, example 2, okay? The same vehicle, but B is traveling in the opposite direction. So let's do question 2. The same. So I'm going to put in my initial car here, like so. And I'm going to say mass equal to 1,200 kilograms. My velocity this way is equal to 33.3. Okay, 33.3. And I now say this one over here, my mass is equal to 800 and my velocity is equal to 22.22, and it is that way. Can you see I put my little arrow showing my directions, right? That is so that I don't make a mistake when I put that is my initial. Okay, now I say this is initial. And the next one I'm going to do final. Yep, this is all you're ever going to do. So I say, right, the final, it says the wreck moves off, all right? Let us say that we've got this goes this way, that goes that way. So therefore my mass now is going to be 2,000, and I assume that velocity final is in that direction, okay? But let's say we choose the opposite way, just to make life difficult. Our logic says to us, this one is faster, it's going to push that one backwards. But let's say when we do it, we say the velocity is going to go that way, right? So let's look at P initial. Okay, P initial is going to be, once again, car A is 1,200 times 33.3. This guy, right, there they are. And minus 800 times 22.2. Minus why? Because this is a negative. It's going the opposite way. In other words, I have chosen that direction as positive. Okay. Not that difficult if you think about it, is it? Well, then, suppose, nothing really is it? So we say that. Therefore, we get a momentum here of 22,182, I think, kilogram meters per second. Now I take my P final is going to be equal to mass 2000 times minus V final, because it's negative. It's going this way. I said anything going that way is plus. This way is minus. Therefore, what do I do now? I put, let me move up a little bit. I put P final equals P initial, or the other way around. Therefore, minus VF times 2000 is equal to 22,182. Therefore, minus VF is equal to 11.1 meters per second. Therefore, VF is equal to minus 11.1 meters per second. And no, guys, this is not where we throw up our hands in horror and say, oh, I've done something wrong, it's negative. What does it mean? What did the minus mean? It means that we're going the opposite way. So we chose the wrong way. Look, we said this way. So our wrong chosen direction. Correct? That's all it says. It means that the final is 11.1 meters per second to the right. And you must always tell the teacher stroke examiner and yourself, tell yourself which direction it's going. Why? Because it's a vector. It's got a velocity and it's got a direction. So we have to stipulate that. Okay. Let's now have a look at the next question. Question number 3. We're filling rail trucks with coal in an automatic feeder as shown. All right. So what we've got is we've got a rail car. Okay. There's our rail truck. This is question 3, example 3, question 3. It doesn't matter. So the rail truck is moving along this way. Okay. And it tells us that it's got a mass of 5 tons. Tons doesn't compute. We don't use tons. We use kilograms. Step 1, that is then 5,000 kilograms, right? That's what we do. So our rail truck, and it's moving along this way at V equal to 2 meters per second. Now over here, okay, above the railway tracks, put in some wheels if you like, just to be, above the railway tracks is a silo, right? So our truck, car, whatever is coming along, and as it passes this point, okay, it trips a lever and the coal starts flowing out. When it gets here, the coal stops, so that as the truck moves on, there's no coal flowing out, okay? Obviously, it's not 100% fail-safe. Bits and pieces of coal come, but in general, that's how you fill up a truck, okay? Right, then afterwards, all right, there the truck goes on, okay? There it is, and we say, right, the velocity, okay, V equals, we don't know. And let us say the silo loads 3 tons of coal. Well, what does it mean? It means that the new mass is equal to now 8 tons. The empty truck was 5 tons empty, plus 3 tons of coal, right? So it's 8 tons, which is 8,000 kilograms as it moves away. What's the velocity? Well, this is an impulse, type problem, isn't it? It's a momentum. So we say, right, initial, P initial is equal to M 5,000 times 2, which is equal to 10,000 kilogram meters per second. And after this collision, okay, my P final is equal to 8,000, whoops, not 80,000, 8,000 times V final. And what's the next step? The next step is put them equal to each other. So therefore 8,000 V final is equal to 10,000, therefore V final, and if you divide it, 1.25 meters per second. And you'd say to the right. All right? That's the velocity of the truck. Quite straightforward, is it not? And as you can see, I'm hoping that you're seeing now that the sketch, because when we get to projectile motion, when we get to energy, if you make the sketches, really, it's so worth it. You won't believe it. Example 4 is one of my personal favorites, okay? Example 4, I call it my astronaut problem. Whoops, not naught spelt as in that way. Astronaut. The astronaut problem. All right. What they tell us there's an astronaut floating along in space. Okay. And this astronaut is floating in space, and I'm just going to draw him over here, and I know that's pretty terrible. He's floating along this way at 1 meter per second. All right. All right. That's what they've told us. All right. Then they tell us that the astronaut, okay, wants to change his direction. Okay, so this is initial. Okay, this is the initial problem, isn't it? Okay, now he says he wants to go back to the space station, and he needs to get a velocity this way of 0.5 meters per second. Please note that by drawing it, they could have given me some other information and asked me to calculate V. All right? This is the beauty of the drawing. You put in what you're given. Circuits, I'm going to say the same story. Okay? So we say we've got that. All right? Then they say, right, the mass of the astronaut is 250 kilograms. Okay? Obviously with him in his spacesuit. Right? So now I draw my little astronaut here. All right? And what did he do? Basically, he spurted out a mass of gas and a velocity of gas. All right? Let's say they tell us the velocity of the gas was 25 meters per second. Okay? The mass of the gas we don't know. The mass of the astronaut, okay, and his thing after this is 250 kilograms. Okay? We've got the mass of gas over there that was spurted out. So we've got our astronaut. I don't really have an astronaut, but we got this astronaut floating along over here this way, and all of a sudden spurts out some gas. There's a column of gas. That gas has a mass. That rhymes. So he spurts it out, but it's controlled, right? Each time he spurts, it comes out at 25 meters per second. So that mass is there. So what was the initial mass? The mass is 250 plus the mass of the gas, correct? Critical that you see that. You've got here the mass after the gas is left of 250. Therefore, the initial mass was that. Okay, now it's quite straightforward. P initial is going to be equal to 250 plus mass of gas times 1, which is equal to 250 plus mass of the gas. And remember, this is positive that way. So therefore, this velocity here is negative. So P final is going to be equal to mass of the gas times 25. because this is the positive, right? It's going out that way, positive. Minus 250 times 0.5, correct? All right. So therefore we've got P final is 25. That's what happens. I knew at the time when I set this problem that I was getting myself into trouble with 250 and 25. Doesn't matter. 25, come on, times mass of the gas minus 125. And yeah, what do I do then? I put them equal to each other, don't I? I say, right, initial is 250 plus the mass of the gas, okay, must be equal to, this was P initial, P final is 25 mg minus 125, and I hope you can see that that's quite straightforward to solve. All right, you've got mass of gas on both sides. Yep, like that. So therefore 250 plus 125 must be equal to 25 mg minus mg, which is equal to 24 mg is equal to 375. Okay, therefore mass of the gas required 15.625 kilograms. Okay, and when we've done ideal gases, you'll be able to work out what volume that is, what pressure, all sorts of stuff that we can do with it. Okay, not too bad. Okay, if you go back to your textbooks, these are the problems you'll see. Try and break them down into that kind of problem. Here's another one, okay? A last one that we're going to do is question 5. Question 5. Okay? Just take this up a little bit. Question 5. We've got 2 people in a boat, okay? Once again, this was one that was sent me, okay? And you've got 2 people in a boat. The one person weighs 60 kilograms. The other person weighs 80 kilograms, okay? And they are sitting in a boat, and the mass of the boat is equal to 100 kilograms. All right? Straightforward. This is the initial, and they are at rest. So the velocity here is 0 meters per second. Straightforward, isn't it? Okay, what do I do next? Next I say, right, that's the initial. So P initial is going to be 60 plus 80 plus 100 times 0. So the initial momentum is 0 kilograms, kilogram meters, kilogram, come on, kilogram, come on, kilogram meters per second. Okay. If it had been moving one way or the other, if it was moving this way, I'd give it a positive. If it was moving that way, call it a minus, okay? Just so you can be able to add the momentums at the end of the day. Right, then what they tell us is they say, right, that then what happens is that this person dives off the boat and this person dives off the boat, okay? They dive at 2 meters per second relative to the water, and this person dives at 1 meter per second relative to the water. What happens to the boat? Okay. Well, now what happens here? Well, the boat, we say, let's assume the velocity of the boat is equal to that way, VB. So the mass of the boat is equal to 100 kilograms, right? So now we've got 3 separate momentums that we have to work out. The mass of the person here, the mass of the boat, momentum of the boat, and the momentum of the person who dived off the opposite way. So we go P final. Right, P final is going to be equal to, let's have a look. First of all, what's the momentum of this person? Well, it's 2 times 80 plus, we said the boat this way, VB times 100, isn't it? Okay, and then minus 60 times 1. That person, momentum is minus 60 times 1. Don't worry, that's the usual error point. Just make sure when you've done one or two of them, you'll see it and you'll be able to put it into your drawing. All right. The next step, the last step of this is what are we going to do? Whoops, not rub it out. We're going to put P initial equals P final. Therefore, we say, okay, 160 minus 60. So P final is 160 there. Minus 60 is 100 plus 100 V boat. Okay. Therefore, we say, okay, minus 100 equals 100 V boat. Okay. Therefore, V of the boat is going to be equal to minus 1 meter per second, which means the minus there indicates I had the wrong choice. Chose wrong direction. I chose the wrong direction, right? That's all that's happening here. I'm choosing the wrong direction. And all that we're going to do here now is we say, okay, therefore, the boat moves at 1 meter per second to the left. I chose right here, and in actual fact, it moves at 1 meter per second to the left. Okay, that I would say simply is that. Okay, please, with momentum, do the drawings, guys. I'm going to start projectile motion next. Very simple section. If you just follow the simple steps that we're going to talk about and break it down as it is. Momentum, the same thing. Okay, what do we do? There's your recipe. Draw it. You draw your final, draw your initial, put in what you know. Watch out for things like an elastic collision, because it means that the kinetic energy is conserved. Okay, those are the straightforward ones. Okay, hope when I do some exam prep ones for grade 12, we'll add in some straight out of the exam papers that are around. Cheers. Have a good one. We're going to go on to projectile motion in the next session. Have a super day. Cheers. Bye.